So we have Enda Ward, he's from Valeo, he leads the camera architecture group down there, and he's going to talk tonight about automated driving, the key technologies that enable this, and the potential changes for society. Enda.
So, hello, thank you very much. As Sarah Jane said, my name is Enda Ward. I'm working down in Valeo, based down in Tuam in County Galway, for anyone who knows it. We have about 1,200 people working there on site, and we've been working on camera systems, vision systems there for the last over 10 years. So I guess the area of automated driving, as we call it, self-driving cars, as I'll discuss the levels of it. Automated driving has different levels. The ultimate goal is the ultimate self-driving car. You sit in, it collects you. But maybe to give you an example of where the technology is going and the use cases and examples, an example of the challenges that it encompasses would be how I got here this evening. So I live in Currafin, small village in County Galway. Typical infrastructure of a small village. I'm afraid it's not quite a smart city. We have got a church, a football pitch and a pub, so the three main points are there at least. But to get from there to here, there's a couple of obstacles we have to overcome in an automated car. First, the simplest option is how do you get out of the driveway? Okay, so the car needs to figure out how do I get out of the driveway in a safe manner. The next thing is you have to navigate. So I live in a small estate, navigate through the estate safely, watch out for small children. Then you get out on the road. Now, I live in a rural area, so there's no lane markings. You drive down that, you avoid vehicles obviously, and get through the junctions. Next step is you get to Athenry, small town, medieval town, not designed for automated vehicles. So again, that's your next challenge. And then you get on the motorway, and that's where it's easy. And that's most of the stuff you see from automated vehicles that are on the road at the moment has been that for the last number of years. And that would be the first stage of automated vehicles on the road. In fact, that exists already. And that's why I say there's various levels of automation. The simplest level is cruise control. So if you sit in your vehicle and you hit cruise control and you set 120 kilometers an hour, the vehicle is controlling the distance, the speed you're traveling at. The next stage is you say, okay, I want to make sure that I don't hit the car in front. So that's adaptive cruise control. So it will slow down if the car in front is too close. As you move from that, we're at what we call the different levels of automated driving. So we have level 1, which is your simple cruise control use case. As we move to level 2, we are what we call the Tesla level of automated driving, where you control the steering as well. So for example, we can stay within the lane, and we can control the speed. And the big jump, which everyone is working on at the moment, is to get what we call level 3, level 4, and level 5. So level 3 area of driving is essentially where you want to create a maneuver. So you take off your hands off the wheel, the vehicle is now in control of the maneuver. So this technology will come to market this year, it's expected with Audi, where you have traffic jam assist. So if you're sitting in traffic jam in a city, for example, people are stuck in gridlock and they want to navigate through it, and you see this as a free lane, the car can navigate out of its lane when it knows it's safe, move into that lane and drive forward. The big jump then is the Holy Grail is where I would have said, and I suppose referencing back to the perfect IoT use case, that I would know from my diary that I need to talk tonight in Athlone, that it would have arranged to get a car to pick me up, that the car would drive me here automatically, that the car would drop me outside, that the car would possibly then, I'm going to be here for 4 or 5 hours, would go off and do something else. Perhaps rent the car out for other uses, deliver packages. And that's the ultimate goal of where we're going. And that sort of links in, I guess, to the smart city concept. Because with that use case, in fact, you have a huge car park here, half it's unfilled. I'm guessing when the rugby's on, it gets a bit busier. But in theory, that could be an additional practice pitch, or you could make this venue bigger. So you have huge parking spaces to hold cars which aren't occupied or used most of the time. In fact, most vehicles are probably operated maybe 4% of their lifetime. And in that use case, you are often doing relatively small distances at low speeds. In fact, the average speed you're doing is maybe 30 kilometers an hour. So again, back to our use case, we've driven here, we've got here, we've arrived at the venue. I have another challenge, is I need to get home. So that simple example, I drove up on a nice sunny evening, driving back home at night time, or if it's foggy, or if it's raining, or if there's snow, etc., is a completely different use case. And these are the big challenges that are facing, I guess, what we call self-driving vehicles as we move forward. But there is a huge advancement in technologies to push that. One of the big challenges that is considered as we move from what we call a level 3, where the human's in control, to a level 5, which is your Google level, it can do everything, is how does the driver take back control in the case of an incident? And that's one interesting aspect that a number of car companies have come out with and said that they can't. That there's a possibility that, if you're sitting in a car for most of the time and the car drives itself, and after an hour it says, oh, I have an incident, how do you do it? So you have a reaction time. You're sitting back reading the newspaper, looking at your tablet, and you're now told you need to react to an incident. So it's an interesting challenge and dilemma that face the technology. And hence there's this, you see lots of technology, lots of test beds around the place, but there is a big push, and we'd say in the next 5 years these key technologies will start to gather pace and arrive on. But I don't think it's going to be a big bang approach that we're suddenly going to have self-driving cars everywhere. As I said, the key core technologies actually exist already in lots of vehicles that are there, and they're gradually adopting. So, as I said, the two use cases have been a key challenge. One was during daytime, the other during nighttime. We then look at the, core technologies which make that up. So, there's two key areas, I guess, as part of that. First is we define different levels of driving. So we have low-speed driving and high-speed driving. As I said, the high-speed manoeuvring is relatively simple. You drive on the motorway, you stay in lane, try not to keep out of lane, don't waver too much, and you should be okay. The bigger challenge is navigating around the car park in here, low-speed manoeuvring, reversing out of the driveway. And there's two segments there. In fact, a lot of the technology we work with based down in Galway is on the low-speed manoeuvring applications. So we have automated parking. So for example, in the E-Class vehicle which launched there last year, you have a car which, with the touch of a button, the vehicle will drive itself. You step out of the vehicle, you get an iPhone, and you control it. That in itself is self-driving technology which already exists. In fact, this sort of ECU here, which is a PCB, has enough electronics on it to enable that. That technology is on the road. So as you see, the key building blocks are starting to come together to enable that. I suppose we move to what were the key technologies that made this enable or brought this technology to pass. There's a number of key sensors which we use. In Tume in particular, we develop camera sensors. So similar type image sensors as you would use in your mobile phones. Same type of technology we use, where you sense around the vehicle. So we've been developing these for over 15 years now. It's funny, I started over 10 years ago. When I started working, people says, what do you do? I work with rear view cameras, and said, why would you put a camera on a car? It was an alien concept. Whereas today, it's, I think, commonplace. It's in the news every day of the week. So rear view cameras have been the first enabling technology to bring that onto the market. Then we've developed surround view cameras. So it's a surround view camera system. You essentially have a 360 view around the vehicle. You have complete view of all people, pedestrians, obstacles around the vehicle, which you can then utilize as part of your detection cocoon. First stage is you can view it. Next stage is you add algorithms to analyze that. Other technologies which have come along is LiDAR. So any of you are familiar with, I've seen Google cars driving around with large testing equipment on the top. They often have what's called a LiDAR sensor, which is a laser sensor. And with the laser sensor, you can detect with high range accuracy up to hundreds of meters the distance of a vehicle in front of you. So 100, 200, 300 meters, you have high accuracy. So this is an example of a LiDAR sensor which would be fitted on the front of a lot of self-driving vehicles. And the other technology then is radar technology. So radar technology, interestingly enough, when we talked to the Ericsson colleagues, where they're working at 28 gigahertz or thereabouts for transmission technology, radar uses 24 gigahertz for detection of objects, 79 gigahertz. So similar types of bands used for completely different purposes, but a lot of the base technologies can be reused. So how did we jump from simple rear view cameras to suddenly autonomous vehicles, self-driving cars being available so much? There's been a couple of, I guess, key technological revolutions over the last 10 years which have really brought this stuff into the marketplace. The first one really was Moore's Law. Okay, Moore's Law has been around for a long time, where chips get faster and faster, and we have got to a critical point where the technology is now saying, yes, we have enough computational power to process images, to process data, to allow for a self-driving vehicle. The next stage has been the consumer electronics explosion, I would say. So when you consider, as was mentioned earlier, the iPhone isn't even 10 years old. So if we look back to 10 years ago, iPhones didn't exist, smartphones were in their infancy. In that 10 years, the technology has evolved so rapidly, both in terms of image sensing technology, the video processing capabilities of those devices, low power, connectivity, and that's ushered on a new revolution. But the other key points have been big data, as I said, connectivity, but also in 2012, I suppose from a computer vision point of view, there was a landmark event which happened. So there's a computer vision challenge which is held every year, where all the leading researchers around the world try to detect against a particular data set. And in that data set, there's millions of images. And based on that, you write your algorithm and you say, this is a cat, because everything on the internet has to be a cat or a cow or a car. And the algorithm works against this and tests it. So back in 2011, the average error rate for this algorithm was, from all the papers around the world, was about 30%. So for every 7 pictures that you look at, or 10 pictures you look at, get 7 right, 3 wrong. In 2012, new technology came along, well, not new, but was applied to this space called deep learning, artificial intelligence-based classification. It was applied to the same problem, and it jumped from 27% down to 15%. So previously it was 1% decrease in error, and suddenly you had this 10% jump. Today, that error rate is down at sub 3%, which means for every 100 pictures you look at, you get 3 wrong. Any ideas what human recognition capabilities is at? The error rate is actually 5%. So computer vision for this particular use case, now I will add that, the robots aren't taking over yet, Terminator isn't outside the door, don't worry. But for that particular use case of deep learning, you were able to improve the performance so much that we've now surpassed computer vision of the human. Again, for a very specific use case. But what's happened because of that, the money that's been pumped into this use case, the chipset vendors, the likes of NVIDIA, who used to make, well, still do make, but were very strongly based on GPUs for high-end graphics PC stations, says, hey, our core chips are actually very ideal to this application set. It says, we need lots of computational power to do this, so let's invest all our money in terms of billions and billions into this space. And all the key places are doing it. The likes of Google, Alexa was mentioned earlier, for example, for control of lights. That all uses deep learning technology. Siri, Google Home, sorry. All these technologies are based on deep learning, and it's evolving very, very quickly and machine learning based. And the same technologies are also being applied to all the other sensors in the vehicle, so not just for computer vision, but also for the radars, for the LiDARs. And because of that, you're getting to a place now where you can rapidly develop the core technologies to analyze a scene, to make decisions. And this is, I guess, where we're at a key point which has really pushed the technology very fast. Around that same time, because a lot of the key technology players were in Silicon Valley, you've seen this push that it's Silicon Valley-based companies who've changed the whole, I suppose, view of the automotive industry. Automotive industry has been based out of Detroit for 100 years out of Germany. They've been even in Asia and Japan. They've been the key players which have drove things. When Elon Musk came along and says, I'm going to get cars on the road, I'm going to do it, I've got the money, I've got the willpower, he done it, he's pushing the vehicles onto the road, and it's a different mindset. And that's the same thing we've seen from Silicon Valley. Google cars have been on the road for the last 6-7 years. Apple car was spotted in the last couple of days, apparently testing. In fact, in California alone, there's, I think, 29, Valeo have a vehicle out there as well, which are licensed to test self-driving vehicles. And as we talk about smart cities, again, that's another application set for a place like Ireland. We are a self-contained unit with very controlled environments, and it's a potential future set where we need to consider from our legislation, our laws, our test beds of how we enable self-driving vehicles in that. So really, it's created this mass revolution, this real acceleration. And the other reason, I guess, behind that has been these big players aren't investing billions of dollars in it for the fun of it. So the likes of Google, why are they making a self-driving car? Apple, are they, aren't they? But what I expect to happen beyond that is it's not just about having a self-driving car, an automated car. What it creates is effectively your next smartphone of the 2020s. It's, for most people here today, they're probably spending half an hour, 1 hour, an hour and a half, maybe 2 hours commuting every day. And that time, they're basically sitting at the wheel and have limited control of what they do. Whereas that 2 hours could be respent at something else. It's a new vehicle, a new medium to communicate, to use lots of time during the day. That's one motivation behind the whole automated car experience. The other big motivation behind it, as I says, is the completely different business models. And that's where the likes of an Uber comes in. So Uber have been on the road, working, as you're familiar, they're similar to Halo or My Taxi in Ireland. I don't think Uber have limited cars, I think, in Dublin, but they're growing. But I think everyone's aware of them worldwide. And the key business model Uber has been based on has been to, okay, we're going to go to all these cities, we're going to make vehicles available at whenever you want it. So you say, I need a cab. As far as the taxi driver is concerned, they don't know where you're going. And the core business model behind that is always availability, that you're not turned down because, you're only going to 10 metres up the road, or I don't want to do that run. So it provides always on availability of transportation. And that key concept is a key enabler of, again, the smart city concept. So first step has been, okay, we need to get all these vehicles on the road. And one thing Uber have found as part of their development is they can't get enough vehicles on the road. They can't get enough drivers on the road. There's also cost models involved in that. Of at a point in time, your most cost, the largest cost of your implementation can end up being your driver. And this is, I think, a common trend in society. We need to see how it impacts on things. Is there will certainly be trade-offs in automation versus jobs, and that's always a key challenge, and new environments will open constantly. But in that particular use case, it does change the complete business model. Car ownership. So again, back to Dublin, we have congestion. Who owns a car? Two of my brothers live in Dublin. They don't own a car, and they have no intention of owning a car, and I can't see them ever own a car because there's no need for them to own a car. If the transportation, public transport exists, they rent a car. If they come down, they give out to me and says, how do I get to your house? I have no idea. There's no bus service. So getting to Galway, in rural Galway, it's not so easy for them. But in Dublin City, it doesn't make sense. But being able to be available when you need it for whatever purpose. So, instead of having a Yaris, you might need a Yaris to drive up the road, or if I'm going camping at the weekend, I need a big SUV. So you rent the vehicle you want. Now, rental models exist. That's fine. So where does automated cars come into all of this? Well, the concept is availability, so that you dial it in, it comes and collects you. It's there, it's yours, it's outside. So rather than me having to go down to the Hertz Rental Centre, drive down, that takes out the convenience of it. And if we go back to I think the comment was made earlier about this, the context of what you're looking for, working through the day, knowing that what time you will wake up. I think you were talking about your alarm clock. The same concept comes in. It says, I'm going to Dublin, or I'm going down to Cork on this particular day. I have a fishing trip. Okay, this vehicle will pick you up this time. So it changes the complete business model of how and relationship we have with vehicles. Instead of having vehicles clogging up car parks, we can potentially create new spaces for recreation. We can or use them for housing needs, for example. And also having vehicles married to, I guess, what our needs are for the particular application. The other point, as I said, the last point it makes out then really is how does that help in terms of how does that impact on how we utilise vehicles into the future? Where does their role in society fit? And that goes back again to the smart device concept. That the vehicle suddenly now, okay, we'll transition. There will be a transition period, 10, 15, 20 years, I don't know. Self-driving cars are not just going to jump on the road and be everywhere ubiquitous in the next 5 years. It's going to take time. Market estimates are that 2025 to 2030, 5% to maybe a 10% of automated vehicles, highly automated vehicles will land the road, which is still a tiny proportion. I made a comment earlier about Bluetooth as an example. Bluetooth's been around for 20 years, over 20 years. But in the last 2 years, 3 years, it's exploded. Everyone has smart speakers, can connect their TV. And I would expect something similar with automated vehicles. They will come in, they will gradually expand through society. But as they do, they enable completely new ecosystems. As mobile phones have transformed society completely, I imagine that smart transportation will do the same. So that's high-level overview. Any questions? Thank you.
Thank you. So I'm probably the only Swedish person in the room. Very interesting speech, thank you. How do you think, I think that the most difficult thing in the vision of the self-driving car is the introduction of it. How do you see that happening when will the self-driving cars be on the road next to the next door idiot who tries to overtake them and cheat the queues and that? Or will we have to turn to the cities and ask them to say, within this limit, you can only use self-driving cars? Or how do you see that happening?
Yeah, it's good. Actually, I had it down as a topic I meant to discuss. You're right, coexistence is key. And coexistence is one of the most challenging things. And I think, as you discussed, coexistence of 5G and 4G and 3G is the same problem. It'll be constrained space, I think, realistically. So when we talk about a level 5, so the ideal, perfect Google car will drive everywhere, do everything, that's a little bit more challenging to realise, because the reality of it is, for example, BMW are in discussions around Munich that would be a dedicated lane. So it may be a bus lane could be used for automated vehicles, for example, or a taxi lane, or your, in the US you have the carpool lane, for example. So I expect there will be particular use cases, first off, definitely. There may be in restricted zones. It may be only on highway driving, for example. So we'll have to develop with that, definitely. The sensor technologies which are being developed for sensing are designed primarily, to be honest, to compensate for everything that can go wrong around you. In the ideal world where everything's automated, in fact, it changes everything. If everything was automated and we had smart cities, in fact, the car doesn't need all the safety protection zones it has. Everything that's developed in the car is to protect you from when you crash. Okay, you've got all this bulked up mass around you because they crash. Now, if you eliminate crashes, which is not going to happen overnight, but the ideal utopian goal is you get to that. If you do that, then it totally changes the vehicle infrastructure. But I definitely think it will be in a more constrained, controlled. And it's something I think that governments are grappling with, because government pace of change and legislation versus technology drive aren't necessarily aligned. But legislation needs to manage that, certainly, and how it's introduced. And there's not going to be a global standard either. So that's why you've got the likes of California, Nevada, introducing these initial laws just to get self-driving cars on the road, but it will be localized, controlled, and it may be driven by economics. Detroit will want self-driving cars. Germany will want self-driving cars because that's a core of their infrastructure. But I think there's opportunities, again, as I said, in the likes of Dublin and Ireland, certainly as a test bed, but also to think about how that infrastructure, because it's stuff you need to plan for 10, 15, 20 years. You need to start planning for it now. Yeah.
That's great. Just recently we were putting in a lighthouse bid and working with some German city, and BMW were involved in the consortium, and they started asking us questions about would we be interested in doing this in Docklands or Dublin Port. So I had to go back to like all the top people who manage transport systems, and they all looked at me like I was crazy. Like, what are you talking about? And I was like, this is coming down the line and no one's thinking about it, you know. So I think there's a mindset here where we don't really realize that some of this stuff is happening faster than, you know, we're making decisions. And then it comes down to we're upgrading all our lighting. I talked about our lighting infrastructure, but you can actually, if you're smart, you actually can upgrade that in a way that can assist navigation and drone deliveries and all that. But no one's thinking about this, you know, by putting in simple pieces of technology in that infrastructure. And this is a 15, 20-year infrastructure play. We're not thinking about it now. We've missed that opportunity. Yeah,
exactly. And I think on that point, it's back to your point of there's two levels of data. There's definitely the high-speed video type data, the high terabytes of transfer that you guys are talking about from a 5G. As an example, an automated vehicle is estimated to generate 4 terabytes of data every 90 minutes. Okay, that's a colossal amount. Not necessarily all that will be transferred back, but ideally you would transfer it back, particularly in the learning stages, because you want to learn everything, because all these deep learning algorithms are all based on data. And the more environmental and experiences you have, you do that. But back to your simple concept of knowing that car A is here and car B is there, that's a tiny piece of data. And your simple smart sensors and all the lampposts can have that information. They also can have localization information to say that this lamppost is at this point in time, and if I can see that with my camera, I know where I am. Because, for example, in the city, GPS doesn't necessarily work very well. So there's huge opportunities, definitely. And it needs to be thought about now, yeah.
I am just wondering about how will people trust self-driving cars? You're literally putting your life and your kids' lives in the hands of a technology. And we all know that technology has teething problems.
Yes, and I think an interesting point, so there's been a number of incidents, in particularly I think with Tesla have had the most high profile. There was a couple of crashes last year. And an interesting talk was, it came out, BMW have announced this big collaboration with Intel and a company in Israel called Mobileye, who were very involved in designing technology for automated driving, who Intel have just acquired or in the process of acquisition for 15.6 billion, which was one of the biggest investments. But interestingly, they came out and commented and says, well, that's why we're not putting self-driving cars on the road now, we're putting them in 2021, and they will be in controlled environment. So in an automotive environment in 10 years, it has to be down to extensive testing, continuous testing. The technology cannot just come in overnight, and that's why it has to build on these building blocks. So the same cameras that we will use for self-driving vehicles, we've been working on for 10 years. So the core bricks have a certain robustness, reliability. You have to have all these safety checks. But it does, you are correct, it needs consumer confidence, certainly. It needs the right governmental watchdogs in place to ensure that. But also, the bigger challenge for automated driving is the benchmark is actually a lot higher. So I don't know what the road deaths were last year in Ireland, 300. If one person dies because of an automated vehicle, it'll be, computers can't control it. So the benchmark is so much higher. But it really comes down to having, as I said, all those checks and balances in place. The traditional OEMs, I think, know that because they have come from places where they've had huge warranty issues, recalls, it's big money. The Silicon Valley players, maybe it's new, we'll get something out, an iPhone. So that those two worlds are starting to realign, I think, and understand the challenges. But lots and lots of testing is the answer.
This is working, yeah. A similar question, actually, picking up on the testing. I wanted to find out a little bit of how Valeo work and what kind of test loops you have in place to get the feedback locally to the teams like that are working on the technologies, so that now you know when you go into the test bed in vehicle use that you've got a bit of confidence in it.
how would you get the...
How does Valeo work today?
In terms of the test information. Yeah. Okay, so we will have extensive, I suppose, test cases which we will develop, not just ourselves, also with the OEMs, but we also have there's standards committees across the automotive industry where you would have standard test cases that you would test to, which are developed. So that's the first starting point. We evolve that, you'll have your various lessons learned strategies within it, but it's really through... it's not, okay, so you've got your high-level test strategies in terms of what you're doing. How do you deal, for example, with a bright scene or a dark scene or, a wet condition or a foggy condition? But then you have a lot lower level than that of how do we deal with 85 degrees on a particular component? How do we ensure the reliability of all these? What happens at a software level? So you have test injection all the way down to the software level. So it really comes down, one of the key things in automotive is requirements. And it's documentation. And it's actually, I worked in medical actually before this, and I would say coming from medical to automotive, it was a highish level of documentation, but I would say automotive documentation now is pushing up to medical level. So it's really having high level requirements, input from all your different test cases. In automotive, we also do something called a DFMEA, which is a design failure modes effects analysis, where you essentially look at all the potential hazards you could have, how it will fail. And the key really for all these use cases is to fail safely. And that's the general strategy.
Hi. Strange question. It came up for Google a little while ago. Let's say, and try to outline a test case to solve this one. There's two self-driving cars coming towards each other, and there's a wall to the right. And one self-driving car has to decide, I can save my passenger by barreling into the other one, or I can save the other passenger by barreling into the wall, thereby endangering my own passenger. How do you solve a situation like that? It's a situation I think Google have put out there as a self-driving car.
It's a very big question, and I don't have the answer. It is. And if I did, I'd probably be sitting on some beach somewhere with No, it is, you're right. There's huge moral questions, there's ethical questions, and it comes back to that point of who do you save? The classic example was in that iRobot film, when he's trapped in the car and you have, 9% chance of saving the child and etc. It's a big challenge, and how you train that. And it's something the industry needs to come up with as a whole. Is one aspect of it, and it's either going to be handled through it. I think it'll have to come through some level of legislation, but responsibility also comes into it as well. And that's one of the big challenges with the OEMs. When a car crashes, whose fault is it? Is it the car company? Is it the driver who isn't driving the vehicle? Is it a particular scenario it's in? Is it the tier one supplier such as us who makes technology? Is it silicon chip? Is it software? So there's definitely a lot of open topics there. Yeah.
You mentioned that automotive cars will have to be introduced in sort of phased and possibly with restraints. Do you see latency at high speeds or decision making at complex junctions as more of which one is more complicated problem?
Personally, I think complex junctions are more complicated. High-speed applications are generally known conditions. So high speed is on the autobahn, but generally on a straight road, you've got a carriageway divide between the two sides of it. You've got lanes ahead of you, and you can see the vehicles with, as I said, this is 300 meters. So you design your vehicle, if it's at 250 kilometers an hour, you need to design the vehicle. You always have redundancy. So one of the reasons we have a camera, a LiDAR, and a radar is we don't depend on just one sensor. So you have a fusion of all the sensors, you make a decision based on that, and you design it based on that. So I actually think the lower speed is a little bit more challenging, because the lower speed is completely anything can happen. But you have the advantage of speed on your side and that you have a greater braking distance.
Is there a projection on the no longer humans are allowed drive on their own, that we will be just completely in autonomous cars?
When that will happen? 100%.
No, is that part of your projection or roadmaps that humans are no longer capable of driving on a road because...
Well, there's actually schools of thought of it that for the likes of Google and Ford have come out to say that, you, as I said, you can't take control of the vehicle. So the Google car doesn't have a steering wheel, which you can take control of. And the concept being that, well, how will I manipulate the situation? There's different studies that said there's one concept is you've got 10-second handover. So, okay, something's happening, I don't know what to do. You have 10 seconds to take control of the vehicle. Another school of thought is 30 seconds. But the studies done which have said it takes 2 minutes for a human to change what they were doing if they were reading the paper, to fully assert themselves and say, right, I'm ready for this crash up ahead. Right.
Okay, we'll just take one more question and then we'll finish.
Yeah, actually, this is not a question, but the answer to all this question: use 5G and IoT. Plan well.
Sorry, but
Use 5G and IoT. Plan well. For the first question too. Plan well, and you know the two cars coming in front of each other. You won't come in that situation if you use 5G and IoT. You know that there's a car coming.
yeah.
You won't face the same problem at the junction. Use 5G.
Yeah.
Yeah.
Okay, that's it for tonight. Thanks very much.